In this unit, we're going to focus on what are called trig identities. Okay, so we see several different identities that we're going to be working with in this lesson. So there's reciprocal, tangent, and Pythagorean identities. So looking at all of these, it may seem a little bit overwhelming at first how many there are and exactly how on earth you're going to be using them. Okay. All of these identities, however, are actually derived from the unit circle, and we kind of delved into it a little bit in the stuff that we were learning about in Unit 10. So if we kind of touch back on that, remember when I first introduced you to the unit circle, okay? So it's a circle on the Cartesian coordinate plane, and it has a radius of 1. So we imagined drawing some triangle on the unit circle. And that triangle, the hypotenuse of it would be a length of 1, since that's the radius of the circle. Okay, that would be the radius of the circle, which is a length of 1. And then the legs of this right triangle, one of them would be correspond to the x value, and the other would correspond to the y value. So then, if we wanted to find the value of sine in this triangle, if this angle theta is located here, so that is our theta, our angle or reference angle, then sine would be opposite over hypotenuse, or y divided by 1, which we found out, y divided by 1, that just simplifies to y. So sine corresponds to our y value in the unit circle. For cosine, if I found that, that's adjacent over hypotenuse, which is just x over 1, that simplifies to just x. So that's why if we have a coordinate point that's on the unit circle, the cosine would be the x coordinate, and the sine would be the value of that y coordinate. Okay, and then we can find all the other trig functions just by looking at this triangle. So tangent, we found out, would be y over x. Cosecant would be 1 over y. We just flip that around. 1 over x, and cotangent is flipped around, so x divided by y. What we're doing when we have our trig identities that we're looking at right now is we're just substituting some values in. So I know that sine of theta is equal to y. Okay, so that means where this y is here, I can actually come in and replace that with sine of theta. Okay, so I can write this as sine of theta divided by cosine of theta. And the same thing with the cotangent function. I could write this as cosine of theta divided by sine of theta. And so that's where we get two of our trig identities that we see here, the tangent ones. Okay, tangent is equal to sine divided by cosine. Cotangent is equal to cosine divided by sine. And then we can get some of the other ones to result. So for example, like the cosecant function, I can substitute sine in for that y there. So cosecant is equal to sine divided by, or 1 divided by sine. And then secant is equal to 1 divided by cosine. All right? So that's where we get our first two reciprocal identities. And then the rest of them follow in suit, and I won't show you how to find all the rest of those, but that's where we get our reciprocal identities. Okay? And then lastly, the Pythagorean identities are actually, if we went to this triangle and applied the Pythagorean theorem to it, so we know that x squared plus y squared is equal to 1 squared, which is just 1. If we substitute everything in like we've been doing, that leaves us with cosine squared plus sine squared equals 1. Okay? And that's one of the Pythagorean identities that we see, except sine and cosine are switched around, but still means the same thing. Okay? Then we can get all of our other Pythagorean identities just by using that, just by using the Pythagorean theorem on that triangle and substituting in our trig functions. Okay? So that's a little bit about where these come from. Today, we're going to be looking at how to use these identities to simplify expressions. Okay, so that's the whole goal. We'll have some expression, like we're given here in the following problems, and we're going to try to simplify these down to just one number or one singular trig function. Okay? So it's usually a little overwhelming if you look at all of these different identities and you're like, how do I use any of these? Which ones am I supposed to use when? So I'm going to give you two tricks that you can use. to help making the simplifying process a little bit easier. So trick number one, we're going to try to change these expressions to either sine or cosine, okay? So any of these identities where I get the results of sine or cosine are going to be especially helpful to me. So for example, this identity tells me that I can take cosecant and change that to 1 divided by sine. Okay, so that's one that's going to be especially helpful, as well as the secant one, which tells me that that changes to 1 divided by cosine. Okay, I want to change everything to be in terms of sine or cosine. So that would work even though it's 1 divided by sine or 1 divided by cosine. This one I don't really care about as much for using this trick. This one is not helpful because it changes a sine or a cosine into something that's the reciprocal identity. So I'm going to prefer that we use the ones where it changes it into sine and cosine, and you'll see why as we start using these. Other than those two, these two trig functions are also especially helpful for that. So the tangent identities, where it takes tangent and cotangent and changes them to be in terms of sine and cosine. Okay, so we're going to especially focus on just those 4 identities and see how we can use them in the problems below. Okay, so for example, let's say we have this expression where I have secant multiplied by cosine. Okay, so I want to change all of this entire expression to be in terms of sine or cosine. Okay, so this one, it's already good to go. It's cosine, just like I would want it to be. How can I change secant so that it's written as sine or cosine? So I can come over to these 4 ones that I highlighted, and I can see here that secant can change into 1 divided by cosine. So that's exactly what I'm going to do. I'm going to change secant. I'm going to rewrite it so that it's 1 divided by cosine of theta. I'm going to multiply this, and I'll just bring this down by cosine, okay? When you have just a sine or cosine function that's already the way that it is, like this cosine function here or sine function, I don't need to change it into anything. It's usually going to be helpful to write these with a 1 underneath, okay? So recognize that, yeah, any number, any trig expression, I can always write 1 underneath that, okay? So the reason that I do that here is now, since these are being multiplied, I can go ahead and cross out cosine and cosine there, okay? So that simplifies. And then all this turns into, all of this simplifies down to just 1 divided by 1. And 1 divided by 1 is 1. So that is my answer, okay? So I got all of this expression here to just simplify down to 1 by changing secant to be in terms of sine or cosine, okay? Let's try that now with this next problem. So here, I see that cotangent can change into cosine divided by sine. So I'm going to go ahead and do that. So cosine of theta divided by sine of theta. Now, I also see cotangent could change into 1 divided by tangent, but I'm sticking with this trick where it's more helpful to change it in terms of sine and cosine, okay? So I've changed it there using the tangent identity. And now I'm going to multiply that by sine of theta. So this didn't change at all, but I'm just going to write it with a 1 underneath. All right, so now that I've done that, the sines can cancel out, and I'm simply left with cosine divided by 1, which just simplifies to cosine. So that is completely simplified down to just 1 trig function, okay? So that was using trick number 1. Now let's go ahead and talk about trick number 2. So this would be number 2. So trick number 2 goes, if you see a trig function, so any trig function, sine, cosine, tangent, cotangent, the reciprocals, if you see any trig function and it is squared, okay, if it's squared with +1 or -1, along with it. So if you see a squared trig function with +1 or -1 next to it, you can try using the Pythagorean identities, okay? Try meaning it might not necessarily work, but if you see it in this format, most of the time you're going to be using a Pythagorean identity, okay? So a trig function, and it's squared with a +1 or -1 next to it. So for example, number 3, like we're looking at right now. Here's our trig function secant, it's squared, and right next to it I see -1, okay? So this particular problem I'm given at, it's drawn my attention to the second identity that I see here, because the first and the third one don't use secant at all, right? When you're given these Pythagorean identities, what you're going to be trying to do with them is manipulate them so that you're able to use them for the problem you're working on, okay? So by manipulating them, I mean that I really want you to think of this +1, the tangent squared of theta, and the secant squared theta to be separate, 3 separate things that you can move around however you like, so that it ends up looking like your problem that you want to use it in, okay? So right now, this is not helpful to me. I can't use this to help me simplify this down. But if I was to change this around so that it looks like secant squared x -1, then that's going to be helpful to me, okay? So here's my secant squared, just like I have here. If I were to have -1 right here, okay, so if I were to subtract 1 from the right-hand side, and when I do something to the right side of an equation, I have to do the same thing to the left side. So if I subtract 1 from both sides, well, that's going to get this 1 to cancel out. So now the secant squared theta -1, that whole thing is equal to tangent squared of theta, because this canceled out, that's gone. So this whole thing is equal to tangent squared theta. Okay, so all of this, I can substitute, or I can replace that with tangent squared theta. Or actually, for this problem, it's using x instead of theta, so we would say tangent squared x. Okay. The x and the theta, it doesn't really matter which one of those you use. They're just placeholders for some angle that you would plug in. So some problems they use x, some problems they use theta. They're just placeholders, so it doesn't matter which one you use. Okay. So tangent squared of x is what secant squared theta -1 would simplify to. Okay. All right. So with those couple of examples, I am actually going to give you a moment to write these problems down, see if you can figure out what they simplify to yourself, and then unpause the video to see if you have the right answer. All right, so for the next problem, here I see tangent of theta divided by secant of theta, so I'm actually going to go with trick number 1, where I'm going to try to change everything so that it's written as sine or cosine, okay? So tangent, I can rewrite that as sine of theta divided by cosine of theta. And then secant, well, secant, I can rewrite that as 1 divided by cosine. Okay, so now that I've written everything in terms of sine and cosine, how would I start simplifying this? So if you recall, if I have a fraction divided by another fraction, I can take that fraction in the denominator, flip it upside down, and then multiply. So I'm multiplying by the reciprocal. Okay, so this is no longer here anymore. I flipped it upside down, I'm multiplying it. And then I can see that the cosines cancel out, okay? So all I'm left with here is sine divided by 1, which just simplifies to sine. So if that's what you got, great job. So you should have sine of theta there. All right, let's try the next two. So here, I'm going to, again, use trick number 1. I'm going to try to change everything so it's written in terms of sine and cosine. Okay, so secant, I can change that or rewrite it to be 1 divided by cosine. Sine is already good to go. I don't need to change that because it's already in terms of sine. So I'll just write that and then put a 1 underneath. Okay. However, that's being multiplied by tangent, and tangent I could change to sine of theta divided by cosine of theta. All right, so now everything's written in terms of sine and cosine. Let's see if I can simplify this down at all. All right, so subtraction, I can't simplify this here because I can't subtract unless they have the same denominator, unless two fractions have the same denominator, okay? However, I can do this multiplication over here. They don't have to have the same denominator in order for me to multiply them, okay? And if you remember, multiplication comes before subtraction anyway. So if I multiply this together, I'm going to get sine squared, okay? Because you can kind of think of this as like x times x times x would be x squared, so sine times sine would be sine squared. And then the denominator for that, well, 1 times cosine is just cosine. And I'll bring down this 1 minus cosine of theta, and the subtraction symbol, I didn't do anything with that. But now that I've done this multiplication over here, I can do the subtraction because now they have the same denominator, and that's what I was looking for in order to do subtraction, okay? So if I do subtraction, I know that the denominator is going to be cosine. What's the numerator going to be? Okay, so the numerator should simplify down to 1 minus sine squared theta, okay? So that's what the numerator looks like. All right, so what do I do now? Okay, so here we go. I see some trig function. It's squared, and there's like a 1 minus that trig function, okay? So since I see this is a cue to me that I'm going to be probably looking at the Pythagorean identities, okay? Specifically, we're going to probably focus on the top one because that's the only one that has sine squared in it, okay? So how could I rewrite this? How can I manipulate this so that it looks like 1 minus sine squared? 1 minus sine squared. Okay, well, if I was to subtract sine squared from both sides, so I have 1, and if I subtract sine squared from both sides, okay, that cancels out here, so 1 minus sine squared, I can rewrite that as cosine squared, okay? All I did is I just moved the sine squared over to the other side, I subtracted it over, and so now that is going to change into cosine squared. Okay, so all of this right here, I can rewrite as cosine squared theta, and the denominator stays the same. Okay. All right, and then finally, now that I'm here, think about this for a second as just like x squared divided by x squared divided by x. How would you simplify something like this, okay? Well, we remember that x squared is just another way to write x times x. And then we could cross out 1 for 1, an x in the numerator and the denominator, so we're just left with x. So we can think about it in the same sort of light here, like this cosine squared is another way to write cosine times cosine. So it's 2 cosines multiplied together. And I can cross them out 1 for 1, 1 in the numerator, 1 in the denominator. So all of this should simplify down to cosine. There's our one trig function that's simplified down to. All right, and then the very last problem that we'll do. Again, I'm going to try to change everything in terms of sine and cosine, so I'll use that first trick again. So cosecant, that can change into 1 divided by sine. And then sine, that doesn't need to change. It's already good to go. I'm just going to write a 1 underneath that. Okay? So it's always helpful to do that if you ever see a sine or a cosine that's already in terms of sine or cosine, because it's sine or cosine. You just write a 1 underneath. And then the next fraction, I have cotangent. So cotangent is going to change to cosine divided by sine. And then tangent would change to sine divided by cosine. All right, so now I've done this. Everything's in terms of sine or cosine. What do I do next? How do I continue to simplify this? Okay, so kind of just like this last problem up here, I'm going to multiply by the reciprocals, okay, of each of the fractions separately. So here in the denominator, I have sine of theta divided by 1. I'm going to take that, flip it upside down, so it's 1 over sine of theta, and I'm going to multiply that by the numerator. So it's no longer there. I flipped it and I'm multiplying. And when I do that, I get 1 divided by sine squared of theta. Okay, so 2 sines multiplied together make sine squared. Same thing over here. So I'll take this, flip it upside down, so I get cosine of theta divided by sine of theta, and I'm multiplying. Okay, so I took this, flipped it upside down, and I'm multiplying. So I get cosine squared theta divided by sine squared theta. All right, so now that I'm subtracting this, I check this out, and they do finally have the same denominator. So I can go ahead and subtract, because they both have a denominator of sine squared. So sine squared will be the denominator, and in the numerator, I should have 1 minus cosine squared theta. All right, hopefully right now you're maybe able to recognize that up here, I have a 1 with a squared trig function, okay? So I'm going to come back to my Pythagorean identities, and I'm still working with this first one here because that's the only one that has cosine squared, but now I'm going to try to rewrite it so that I have 1 minus cosine squared. Okay, so there's the 1, and if I move this cosine squared over to the other side, if I subtract it over to the other side, then I'll be able to use it in this problem. So now I know that 1 minus cosine squared, that is equal to sine squared of theta. Okay, so I can rewrite this whole thing so that it's sine squared theta. So here we go, I just rewrote that, and that's being divided by another sine squared theta. So all of this is finally going to simplify to 1.